Hello and welcome to this week's episode of Automate It, live recording, not live, you're listening to it, from the soon-to-be ex-headquarters of Polymath Robotics, where people are currently looting expensive technical gear from the office. People are grabbing refrigerators, plates, pour-over coffee makers, you name it. If a snobby San Franciscan has bought it, people are walking out with it right now.
Stefan is contributing to the grand tradition here of projecting CEO behavior onto the rest of people say.
I may or may not be grabbing 7 just different pieces of Sonos equipment from this soon-to-be ex-office. Our master tenant is moving out, and hence why people are grabbing their stuff. So welcome again to Automate It. My name is Stefan Axmacher. I'm CEO and co-founder here at Polymath. Across from me is someone who's coughing and wearing yet another robot t-shirt. He's going to a fancy dinner tonight and he asked if he needed to change. And I said, no, it's probably on brand for you to look like a nerd because I'm a loving and kind co-founder. Who exactly are you, sir?
So the t-shirt has a robot walking a dog. So I'm going to call myself, I'm the one who walks.
And welcome to Automate It. This is our weekly podcast that we never miss a week of, where we normally do 2 parts. The first is where we play a game where we spitball together a robot. And then the second is we talk about a topic in robotics. And to be as timely as, lead balloon, this week we're going to talk about the Titan submarine crash from a robotics perspective. And with that, you have Automate It. Oh, wait. There's a breaking news announcement. Stop the presses, slam the brakes on your car, steer over to the emergency lane and do a tier 1 stop. We have a big piece of breaking news about Polymath. Last week we announced an investment by and an integration with Samsara. Yeah. Samsara is a company that is digitizing the world of physical operations. So think dongles that plug into equipment to tell you where they are, their fuel burning, how efficient they're operating if they're doing anything weird. Sitting across from me wearing the robot walking a dog shirt is exactly the man who wrote the integration to Samsara. How hard was it to make Samsara's ERP software command our robots around?
Yeah. So we hinted at this at our last episode, but basically in hacking around, because we had been part of their tech ventures firm or fund for a little bit. And in hacking around and looking at their API, I realized that they actually have a system to command routes to connected devices. And it's a very sane REST API, very similar to what we use. They had a very nice website to try it out, all kind of modern web design. And I realized that their sane commands were a hop, skip, and a jump away from the same commands that we use.
Yep.
So I basically wrote, 80 lines of Python to take input from one API and shovel it to the other API.
In other words, you wrote the world's most innovative and amazing 80 lines of Python.
Yeah.
We should charge a super expensive feature for, maybe like an extra $80,000 for that integration.
Exactly. Yeah. Totally worth it. After having handwritten this, I realized that because both ends use Swagger, I could have even used Swagger's autocode generation to probably do this. I tried it out. It was very wordy. I liked my small version better, but whatever. But yeah, so basically at the end of the day, you could use Samsara to draw a route and say, start here, go here, and end here. Click go, and then our robot immediately picks up and does that.
Yeah.
To enable that, you need a bunch of robotics magic. Yep. So you can't just take a Samsara dongle, plug it into your existing truck, and magically it works.
That'd be nice if that was all a robot needed.
Yeah, well, I mean, you know what? Honestly, if OEMs start to integrate these autonomy driving features, one of these days, sometime in the next 500 years, then maybe that will work. But it won't work quite yet.
Well, going back to our regularly scheduled programming, let's play a game.
Absolutely. So let's see. Business case this week is airport.
And in the airport, we're going to use...
So while Stefan's picking his out, as always, we pick a business topic. So in this case, I've picked airport, and Stefan has picked a tech of...
The tech of depth cameras for stereo.
Cameras for stereo.
Stereo cameras for depth, I should say.
So now using this tech in this business case, we need to come up with a company and see if we can make anything that even remotely resembles reality.
So I feel like a lot of annoying things have happened in airports. And I actually had a chance last week to hang out with some airport people. So I'm feeling like we should do something closer to reality, but we'll still find a way to be ridiculous. So as a little known fact, Dallas-Fort Worth Airport, DFW, has the land area equivalent of the island of Manhattan.
Oh, Jesus.
Yeah, airports
serious?
are actually massive. There's this part where the TSA harasses us for little to no safety benefit. There's the part where we sit in a priority pass lounge to stay away from the unwashed, non-regularly traveling masses.
Okay, communist.
And then there's the actual airport where DFW is that large. Denver International by 2030 is estimated to have about like 3,000 vehicles running around on the tarmac. However, it's actually been an incredibly slow space for automation. The ground operations, I was on stage at Samsara's conference last week with a ground support equipment GSE leader at definitely American, maybe not Delta, I don't know, one of them.
Some airline.
And what he said is like they don't make commercials about what happens downstairs. So the ground operations just kind of have to work. It's hard to make a big show out of. And if you had a robot that ever bumped into a plane too bad, it would cancel out all the ROI you would ever have from canceling every bit of labor in ground support.
So it's like IT. You only ever really think about it if something goes wrong.
Yeah.
Right?
So
like
it's a great place to spend
unglamorous.
lots of money and take large risks.
Yeah.
So that being said, I think we should automate just that. And one of these pieces of equipment, we could do, I think stereo cameras for depth are interesting.
Yep.
In Europe in particular, there's a bunch of problems with GDPR and using cameras.
Yeah.
I talked to an airport who was looking at cameras to judge how effectively planes were landing. And they needed a whole GDPR story about how their cameras weren't capturing personally identifiable information from the exterior of an airplane.
So does that still count, me being a little bit ignorant of this, does it still count if the data never leaves the device? If it just gets wiped? Yeah, it doesn't even matter.
Apparently, if you're walking around in Germany, which is the most strict on GDPR, you see a camera and you don't like cameras because they're sus, you can sue the airline to prove that they're not doing anything weird with that camera.
Even if it's completely disconnected from the internet?
Yep.
Wow. Okay.
So automation's going great in Europe.
Yep.
So that being said, let's use stereo cameras in German airports.
Okay. Assuming we have the GDPR piece solved somehow.
No, they'll be magic GDPR cameras.
Okay.
New feature brought to you by Bosch, probably.
Yep, sure.
GDPR compliant stereo cameras.
Okay.
Maybe we're doing something like a movable stairs. Yeah. So we have our movable stairs. Easy peasy. We use the stereo cameras for driving.
So let's just step back really quick for tech review. How stereo cameras work fundamentally, right? They're solving a trigonometry problem where if you see something on the left camera frame and you see the same thing in the right camera frame, and you know the distance between the two cameras, you can solve for a triangle and get the depth.
And see how far something is.
Exactly.
Which is why I have bad depth perception when I wear a pirate patch all day.
Yeah. Interesting thing, this fails in two ways. One is if the thing is too far, your baseline is going to be too small between your cameras. And so you just, beyond a certain distance, it's so noisy, it's unusable. The second thing is if the thing you're looking at is featureless, like
the side of an airplane,
the white side of an airplane, you're not going to get any depth from it because there's no features to actually match between the two.
So here's what we're going to do with our movable stairs. Step one, we're going to drive on the surface roads around the airport at about 30 to 45 miles an hour.
Wow, very fast.
And then we're going to get onto the apron, which is like basically the part of the ramp that the plane is on that like people board on. And we're going to drive up to the plain white plane and dock with its door.
All right.
So yeah, make it work with stereo cameras. Because LiDARs are stupid and radars are for the Navy.
Are sus.
Yeah.
To use modern terminology. I don't know if that's modern anymore. Anyway. So fun thing. If I can stretch the definition of stereo just a little bit.
Okay.
What you can do is actually project texture onto your surface. And use that as a cheat, right?
So in other words, I have my stereo cameras, and sitting in the middle, I have a projector that's spitting out a grid.
Yep.
And that's making it so I can use stereo cameras.
So you could actually use stereo camera. Yeah. Yep. So it's this pattern called gobo, which looks like a kind of or gobo type projector, which looks like a semi-random pattern.
Okay.
But it encodes unique data. So it's not just a grid, it looks like noise. It looks like digital noise.
I guess that begs the question, like, why do you need the second camera if you know what the grid looks like initially?
Bingo. Yeah, that's how the Microsoft Kinect works, right? Is they have one project. Yeah.
They're spraying me with light.
Yes,
I don't consent to that.
Yeah. Well, GDPR your way out of it, I guess. But yeah, so they'll project structured light and measure it with a camera. And you can do this kind of texture projector hack. I think, again, it will only work in really close proximity.
Okay.
And so I think as you're getting really close,
I mean, the hard thing is like the last meter, really, because like if you're doing movable stairs, Granny doesn't want to jump a meter to get onto the plane because, you know, I don't know. I guess they made them worse in the old days. So it's really that last, like, you know, few inches so that you like nearly touch the plane, but you never hit it hard.
So yeah, I think when we're that close, probably we can use the door features. Like that last few meter, you should, even little imperfections in the skin of the airplane will be good. But it's that middle distance of like less than 100 meters, more than 5 meters.
I mean, we could also cheat and ask every airline to repaint their planes for us.
Yeah, big April tags on the sign of every door. Which, like, you know, I heard this good saying. I forget exactly who said it, but like, I think it was actually Ryan Garapi at ClearPath Robotics. He was saying, you know, you got to count the amount of miracles for your robot company to work. So like, miracle one. Every airline manufacturer on the planet who's going to land in Dusseldorf, Germany, has to paint an April tag.
I think that's an easy step one.
Yeah, definitely. That's like no problem.
You know, if they don't want to, you could just launch like a missile with a spray painting thing on it. You could fly alongside the plane and shoot paint on it. You're good to go.
Even better, the stairs has a little paintball gun, and as it gets closer, it draws out an April tag code via paintball gun.
You know, that's actually kind of an interesting idea, especially if it was like a paint that didn't stick. Rather than projecting light on an object,
projects paint.
Yeah, you just projected like a fluid that, like, you know, rubs off in time, but then you just get close to it.
It'd have to be some sort of like glue-like fluid because you don't want it to run either and change your features as you're trying to measure.
As long as it's adding features, then you're okay.
Yeah, but the thing is, these features, if you start to see them move vertically, right, it's going to mess up your measurement. They're going to run left
So now we know
and
how to dock with the plane. How do we drive at 45 miles an hour?
Yeah, interesting question. You know, I hear all these.
There will be features.
Yeah, we've talked about this before. The like argument of like, well, humans do it with 2 eyeballs, so why can't your robot do it? Humans have a giant brain compared to computers. They have a lot of processing.
I see a lot of computers larger than my brain.
Yeah, still less powerful. Not making any claim on your brain specifically, but I'm sure it's still less powerful. But, you know, especially in an airport that's relatively controlled, you have very defined lanes.
Yep.
You could do a lot of the same cheats like lane following, GPS following, like that kind of stuff. So I'm not too worried about that. All your obstacles on the middle of a tarmac would be fairly large. Yeah. Like I'm not going to avoid.
And once you're actually on the ramp, the operating speed is probably like 2 to 5 miles an hour.
Exactly. So when
like 5 miles when you first enter the ramp and like 2 miles as you're approaching the plane.
Yeah, so very much doable in that sense. I mean, I'm thinking of I think it's one of the Florida airports that has migratory turtles that they have to avoid every year.
Yeah, you just have to watch out for the turtles.
I think we'd probably hit them. Any reasonable resolution camera and compute would not see turtles. And any
just like the Australian opportunity we've had where they said, no, please hit the kangaroos.
Yeah, hit the kangaroo. We want your system to avoid humans, but hit kangaroos. I don't know if we're comfortable doing that kind of system.
All right, so retrofit on the movable stairs that, like, you know, if we're using stereo cameras instead of LiDARs, we'll save a bunch of money. So like your retrofit here might be $50,000 to $100,000.
Yep.
And driving between ramps, probably okay.
Yep.
Doesn't seem scary as long as you're okay with running over a couple turtles.
Yep.
Which I always do it in Mario, so it must be fine. And then we just need to project light onto it.
Or get close enough that the actual imperfections in the door are good enough. Yeah. Yeah.
It seems like the worst technology for the use case, but it still could work.
It still could work, yeah. The nice thing about cameras is that they won't suffer from interference or multipath reflections or anything like that, because these airplanes are shiny.
Yeah.
So actually, camera data might be nice.
Huh.
Might not be too bad.
Well, there you have it. That's almost a real business. It's just the most annoying way to get to one.
So wait. How do we fix the GDPR thing?
How do we fix? Oh, we kill the people.
Oh,
yeah. So we dock with the plane mercifully, and really gently. Then once the people get on the stairs, we take them for a joyride. they can't sue us if they're not around.
I have an alternative approach. Every camera has a big QR code on it.
Yep.
And if you can get close enough to scan it to get more information, it just auto self-immolates. It just catches on fire and says, "Rescue your data now, jerk."
And with that being said, there's our stereo camera movable stairs. So there was about 3,000 articles last week about the Titan submarine implosion. For those of you who don't read any form of news but listen to our podcast, A, who are you? B,
can we sell you a robot?
but kind of fundamentally, a company called Titan Nautical Space or something. OceanGate.
Yeah,
OceanGate,
which is such a great name if you think about it, because it just sounds like a scandal by itself.
Well, it's like the underwater version of Heaven's Gate.
Yeah,
and incomparably
bad.
So they built this submarine to take tourists down to see the Titanic, and I actually think this is like a cool idea in general. Let's use the seeking of adventure by the rich to fund really cool technologies, and then gradually over time they make them more accessible. Like I would love for us to use submarines more than just launching missiles at the Russians. I mean, it'd be cool if we did all sorts of stuff, because I watched Sea Lab 2023. Now, with that being said, they went down to about 4,000 meters below the surface, imploded, and it didn't work out. So, first of all, 4,000 meters, that's not, I mean, it's like some water, but why is that so heavy? Why did that make things implode?
Yeah. So the interesting thing about submarine design is it's drastically harder than spaceships. What's really cool is you could probably
there's oxygen in the water.
Oh, right. Exactly.
Just
fit gills on the thing. Yeah, no. What's interesting is you could take a seaworthy submarine and launch it into space, and it would do just fine until it started to overheat. That would be your main problem, is heat radiation. But anyway, the problem is for every 10 meters you go under the water, you increase 1 atmosphere of pressure.
And an atmosphere, for those of you who haven't scuba dived or don't like physics, is all of the weight of the atmosphere that is hitting you as a person when you're standing at sea level. So every 10 meters deep is another Earth atmosphere of weight on top of you.
Yep.
So like if you scuba dive, for example, every meter or so that you go deep, you have to equalize your ears. Basically, pop your ears to deal with the change in pressure. So you're popping your ears all day, every day. And like normal, like, if you're an entry level scuba diver, you only go like 15 meters, 10 to 15 meters deep. And like more advanced is 20 to 30. And then you're not going deeper than 30 unless you're a weirdo.
Yeah, unless you're extremely specially trained. Yeah. So the other interesting thing is that if you are a deep sea diver or you're working on the bottom of the ocean in these bathyspheres for oil rigs and that kind of stuff, they'll equalize the pressure inside the vessel with outside. And then your walls can be really thin. There's no implosion risk. You can even these deep sea divers who do oil rigs, they even have a moon pool. Like they open the bottom of the bathysphere to dive in and out. But the problem there is that you have to breathe a special mix of helium and oxygen. And when you surface, you got to really carefully surface over hours. Because
basically, as you think about it, the air that you're breathing, even when you're just scuba diving 20 meters deep, is a lot denser because you need more dense oxygen to fill your lungs given the pressure.
Pressurized,
which means that like if you're just scuba diving, the deeper you go, the faster you breathe through your air. However, as you're going deeper and deeper in a little vessel, you have more and more force fighting against your normal 1 atmosphere pressured environment.
Yeah, for these deep sea vehicles, you're going down so deep that it's not feasible to bring enough oxygen to actually pressure match your environment and then come back up to the surface. You'd need to spend like hundreds of hours resurfacing.
I had a particularly deep dive once where in feet, because I know them separately but not independently, an advanced open water diver might go 90 to 100 feet deep. I went on and a dive like that deep might last 40 minutes, whereas a 50-foot deep dive might last 60, 70 minutes. I went 155 feet deep on a dive that lasted 15 minutes and breathed through all my oxygen, needed to borrow someone else's air on my way up.
Yep. Yeah. So
this vessel went very, very, very deep. To be clear, there was under the pressure of 450 atmospheres when it went deep, and then it popped. Yeah. So talking about some of the things that have been talked about with this, my favorite one is, why were they using an Xbox controller?
Yeah, I love that red herring. So,
I mean, listen, like if it's a submarine, shouldn't they be using something really expensive like the military has?
Yeah. Well, actually, if you've seen the reverse story, the Navy has started to use an equivalent Xbox controller for periscope control in some of their on some of their subs. For nothing primary. But yeah, because A, people are comfortable with them, and B, they're cheap. and reasonably robust.
Yeah. I mean, at Starsky, we were using Xbox or PlayStation steering wheels for teleoping trucks. And I remember a couple of people being like, wow, that's ridiculous. Why don't you buy something more expensive? And if you buy a PlayStation steering wheel, you know, a nice rig might run you $500, $1,000. If you want to buy a thing from a truck driving simulator, it's going to cost $40,000 and be worse.
And be much worse.
And be something. Whereas the PlayStation controller, crap, you could replace it every 6 months and you'd come out ahead and have a more reliable system. Because it's been built to withstand that obnoxious 7-year-old who's yelling at you on Call of Duty.
Yeah, exactly. And I mean, like, there's all sorts of questions on should there be a backup system and blah, blah, blah. But this is not the reason the vehicle actually failed.
Yeah.
The vehicle failed because of fundamental material science and design problems, not because of the controller.
So one of the things I read was that they had a senior engineer who like got really freaked out about safety, wrote a big memo, and then like, you know, rage quit / was fired and sued them. I guess how do we parse out whether that person A was raising those complaints in good faith, or B was just saying, no, this isn't safe, and, you know, lobbing safety grenades that would stop them from ever, you know, testing or going out into the ocean?
Yeah. So to back up, even before we get to that topic, one thing that I learned that I just, you know, reading up on this out of curiosity, the vast majority of ultra deep diving vessels are one-time use only. Which I had never known before this. I would have assumed. So of the, let's say, dozen-ish vehicles that have been down to that depth or below that are not military, of course, probably 2 or 3 of them are built to be reusable, if that.
And is that because of all the damage that happens under that pressure?
Material sciences, exactly. So flexure, buoyancy becomes a real problem. So a lot of these use special foams that compress under pressure but can still remain buoyant. And when they've been crushed, they can't be uncrushed anymore without replacing the whole vessel.
So it's almost like the space program pre-shuttle.
Yeah, that's a good, or pre-SpaceX, for example, you know, because the shuttle, they would still replace the entire outer surface.
Oh, yeah. Well, I mean, I'm sure they import the compute from one submarine to another.
Yeah, exactly.
But like functionally, it's a new vehicle.
Yeah, it's a new vehicle. So so it's that kind of that problem of, for in this case, this engineer was concerned about a number of things, but one of the things was the main viewport on the front was only rated to something like 1,400, 1,500 meters in that range, which is not the depth of where the Titanic is.
And the 4,500 meters that the Titanic was at is orders of magnitude more pressure.
Right, because it's atmosphere per 10 meters, so it's not a linear scale, it's a logarithmic scale. So they're really facing a lot more pressure.
And the viewport's a particular point of failure. It'd be one thing if the toilet failed at that depth. That would be a stinky situation. But the big hole to the water itself is something that you probably don't want to fail under pressure.
Yeah, and there's a whole discussion to be had here about the material science of a dome of, I assume, a special kind of plexiglass, basically, that they're using, versus, you know, what it's rated to and what it's tested to versus what it's designed to. So as a good engineer, you never want to design to 100 meters and test 100 meters and be happy. Because your instruments might be slightly wrong. The material might have a tiny microscopic flaw, all sorts of things. So if you want to rate to 100 meters, you should test to some safety margin of, let's say, 200 meters. And so you know for sure at 100 meters, everything's going to work okay.
So, I mean, how do you know that didn't happen for this viewport?
Well, it seems, you know, the content of this engineer's complaint is that it was rated to a certain value. And even though if it could go below that value, theoretically, the rating was such that it took into account these kind of safety margins. So material science-wise, it could go deeper, but nobody would give them the rating because there wasn't the safety margins included. Now, it doesn't, you know, there's still an ongoing thing. They just pulled up the wreckage today. I saw photos of it. It doesn't look like the viewport is the thing that failed. It looks more likely that the carbon fiber material itself got stressed. And again, you know, I'm not an expert in deep sea diving for sure, at any sense, but reading what experts have written, the reason the reusable vehicles are built out of titanium is that titanium does not compress and flex the same way that carbon fiber does under pressure.
I mean, I think that I read was that they bought the carbon fiber itself from Boeing, and it was like not good enough for Boeing anymore. It had outlived its shelf life. Like, what's that mean? What's that likely to mean?
Yeah, so if you've ever built anything out of carbon fiber, it's a weaved material. It's almost like a cloth that's impregnated with a binder, a glue. And what you do is you wrap this material over and over and over around your structure. and then bake the whole thing to solidify the glue into one mass of material.
Yeah.
The glue is kept in an airtight, this whole glued fabric thing comes from the manufacturer and is kept in an airtight roll.
Mm-hmm.
And the glue has a shelf life, just like any other glue. And so beyond a certain shelf life...
So it's more the glue that has a shelf life and not the carbon fibers itself.
Yeah, it's the glue itself.
Yeah.
And so beyond a certain life expectancy, you can't expect the glue to make as good of a bond as it should. It's as if you left glue out to dry.
Yeah.
It's not going to be as sticky.
Yep.
It might not be fully solidified, but it's not as good as it should be. Yep. And it's not going to create as good of a bond as it should be.
Yeah.
The risk of using, and again, not an expert here, but the material science people that I've been reading, they're concerned because this vessel had done the dive a few times before.
Yeah.
But their concern is every time you pressurize and depressurize this thing, you're causing micro fractures. As if you bend a piece of metal over and over and over again, it gets fatigued.
Yeah.
And so the same with this carbon fiber. If you bend it over and over and over again. Can't you just
look at the carbon fiber closely and see oh, it looks fractured, doesn't look fractured?
If the crack was big enough to see with the naked eye, you would leak water at the surface. You would know. So these cracks would be microscopic in scale.
Yep.
And the walls of these vessels, if you look at the titanium ones, are a meter thick. They're enormous.
Really?
Yeah.
A meter of titanium
on the professional ones, yes.
That's pretty cheap, right?
Well, I saw a whole, again, I've been looking into this out of curiosity. I saw a whole video of the construction of the Deep Sea Ventures, what was it called? Something. Anyway, I'm forgetting the name right now. But the other professional reusable craft. And they forged this titanium hemisphere in a special factory with this enormous 1,000,000-ton press, and then machined it to within a micron, another facility. And so this bathysphere main sphere of this professional vessel traveled the world from special factory to special factory to special factory to do these micron level designs, and got x-rayed to make sure that the whole crystal structure was correct, and got depth tested in Russia because it was the only depth chamber large enough to test the thing. And it was crazy, right? So the amount of material science you need to withstand these kind of pressures is ridiculous.
Yeah.
And so if there's these fractures and fatigue seeping into the carbon fiber, you wouldn't be able to see it by eye.
Yeah.
And there's no good way other than taking the whole thing out and x-raying every single millimeter of it to tell if it's beyond the point of failure.
Especially if you're trying to reuse this thing over and over for profit.
No, exactly. And again, they had good feedback, especially the CEO had good feedback from professionals in the field, again, of which I'm not. I'm sorry, I'm saying that the third time, but I want to make this really clear that they should not use carbon fiber because of this problem. Not because it can't withstand the depth, but because it can't withstand the depth repeatedly without fatiguing.
I mean, how expensive do you think a chassis like that made out of carbon fiber is? Could they, for example, have made this vessel and then disposed of the entire carbon fiber body and ripped out the guts and installed the next one in between each trip? I mean, at $250,000 a ticket, they're making $1 million per trip.
I mean, you're making a good point. Part of what I've read is that this particular company decided not to go through the proper channels of certification and safety testing and that kind of stuff. So they seem to have been cutting corners. Yeah,
but I mean, there's an argument to be made that existing standards bodies aren't always good at understanding how you should build these sorts of things.
Absolutely.
And that's not to say that. Yeah, I don't know these people. I don't know why they made the decisions that they made. I'm just not one to jump on you didn't follow all the normal path. Probably the company was out to be evil, right? Because the CEO himself died in this whole thing.
Yeah.
So, I mean, there's an argument that avoiding the standards bodies was because they said writ large, you can never use carbon fiber because of these risks. And the CEO probably had some nice talk track for why that didn't matter.
Yeah. And again, he was correct for 2 or 3 dives or some small amount of dives, right? But the larger thing here is that he was stepping into unknown territory because nobody had, or really not many people had done this sort of approach.
Yeah.
And without this intensive analysis and safety testing, you have no idea when it's going to fail.
Yeah.
And again, because these are microscopic, it could look perfect until it fails. So
one of the things that I found really interesting about this, and I don't know if this is true or not, but it's a nice story either way. YouTube celebrity Mr. Beast claimed that he was invited to go on this trip.
I read that too.
And they gave him a whole safety talking to, and it seems really reasonable, and he just chickened out for one reason or the other, which was a very useful chickening out. But what I think is interesting in this is that they were able to take conceivably or perceivably smart people and explain to them why this was safe, such that they could actually get it deployed, and yet it still wasn't safe. I guess I wonder about the difference between the communication of the safety of systems like this versus the actual safety of systems like this.
Yeah, again, this is a case of us being a startup ourselves. Mm-hmm. You're inherently pushing at the edge of feasible, especially a tech startup, right?
Yep.
We have to deal with safety constraints on our vehicles. We work with a lot of very dangerous looking vehicles in proximity with humans. And you have to balance a safety approach with a progress approach with a whatever, right?
Absolutely.
I think in the CEO's case, again, I agree with you. I don't think he was doing anything maliciously, considering it cost him his life.
Yeah.
But I think...
if he was in fact smart, he must have had reasons to think that this was reasonable. Or he was not smart.
Yeah, no, I mean, again, I don't want to speak ill of the dead. I don't know this person, but the fact is, he probably had good reason to think that it was safe. When you're operating in this kind of startup cutting edge space, you have to balance these risks. And we talked about this before about the safety grenade case. Of we operate autonomous vehicles at Polymath Robotics. Oh, what if a duck walks out into the road and you swerve to the left and you hit a baby and the baby hits another baby, whatever, right? Safety grenades.
Baby dominoes.
Right, baby dominoes, right? You could tie yourself up in knots, and that's not valid.
Yeah.
And it's also productive. And it's also not valid to say we're not going to pay any attention to safety and we're just going to write our code and not care about what happens. We try to take the approach of, we look at the existing safety standards. We're a big proponent of UL 4600, but there's other ones. ISO 26262 is a good one for on-road vehicles. Of here's the best practice in the industry, here's as much as we can read, and here's how we're going to do a documented, reasoned approach with external reviewers who are not tied to us financially. We just pay for their work, regardless if they agree with us or not. And if they tell us that something's not good, we have to make a case for how it's going to be safe and what we're following and what our processes are. And so I think in this case, the CEO was a little bit too confident on their own work to be no, I know better than everyone else. I know how to build this. They're being overcautious. And I can understand that, because if you worked in this field and you get those safety grenade cases, you can get a little bit jaded and be that's a safety grenade. Don't worry about it.
I actually feel like there's a thing where safety grenades lead to net less safety. Mm-hmm. I've heard a story about a particular on-road autonomy team where all there's a group of people who threw safety grenades all the time. They implemented a rule after an incident that any service that had more than X number of lines of code needed to have unit tests. And what they found is the same people who threw the most safety grenades cut their services into 3, so they didn't have to write unit tests on them.
Yeah, that sounds extremely familiar to me.
Yes.
That happens in all industries.
Yes.
Right? There's a good saying in engineering that regulations are written in blood.
Yep.
In that you cannot, as a good engineering team, you cannot predict every single way that something's going to go wrong.
Yeah.
And so it is not feasible to 100% safety case test everything. One thing that you say that I quite like is that you say the denominator of any, or the numerator of any issue is always going to be 1.
Yeah. Or of any fatality.
If any fatality, any injury, anything, right? Even a near miss in safety terms, it's going to be 1 out of a million, 1 out of 10 million. It's never going to be 0.
Yep.
We live in a physics-based world. The best software in the universe is not going to save you if you jump in front of a truck.
Yep.
You just can't stop that quickly. So kind of what I'm trying to get to is that knowing those constraints does not mean you disregard the safety approach entirely.
Yes.
You have to apply the reasoning and the engineering discipline to separate out the real safety case wheat from the safety grenade chaff.
Yeah. And I actually think I see a couple of different ways a couple of different paths that can happen to, let's say, ocean tech or submarine tech to the extent that that is an industry. This could stifle it all, and no one could try to build anything in submarines ever again. And, that's the most likely. Not nothing built, but it'll be way harder to start a
winter
submarine startup. Submarine tourism startup will be harder.
Yeah.
I think in reality, building a system that is intended to go to the Titanic, and instead of just, hand waving past the safety and spending, the bulk of your engineering resources being how do we quantify this risk that will have a 1 in a million or 1 in 10 million chance of everyone dying? That would actually be a massive improvement, because I wouldn't be surprised if at OceanGate it was, hey, stop throwing all these safety grenades, screw you, you're fired. Let's just build a fucking submarine that can go that deep. And that led to a submarine that could go that deep, but not come back.
Not repeatable.
And I think that the right takeaway from this is it's really cool that people took the chance to go to the Titanic.
Yeah.
I actually think that it is kind of neat that there are still risks like this to take in our strip mall and 18 airbags and whatever world that we live in, that there are still risks that you can take where, the engineering was bad and we all die. That seems to me personally inspiring. That is a risk that is available. On the other hand, if you take it seriously, you can build systems that can actually work in these things, and that's how mankind can conquer the ocean floor.
And how it turns it from a foolhardy venture to a risky venture.
Yes.
Which are different things.
Yes.
I think actually, talking more about it, I think it's actually, there's an extreme amount of parallel between this and autonomy robots, particularly because some of what I read is...
That's why I wanted to talk about it today.
Yeah. Surprise, surprise. I think that the thing that I read is that, in particular, this being in international waters means there is no governing body that can come in and say, I'm not going to let you dive.
Yeah.
If you have a boat out in international waters, nobody has any right to stop whatever you're doing.
I mean, I think...
Well, that's an
finish your thought.
Oversimplification. If you go and raid people in the middle of the ocean, I'm sure people will have something to say about that. But right? And I think in a lot of ways, the autonomous vehicles industry has been in that space where they've started to put in regulation, but there's still a little bit of this Wild West kind of, nobody really knows what the right regulations are. It's different from place to place.
Yep.
Some ports of authority have something, again, pulling back to the ocean case. And so it's left to companies to really try to do their best in good faith with the best possible approach they can take. And I think the failure here is not, to your point, that people wanted to do this or that it was a worthy thing to do, but that they didn't actually see this open space and say, we're going to try to build something as applicable as possible. They saw this open space and said, we're going to try to build something as cheap as possible, which is not the right approach in an open space.
Yeah, I mean, to tack on to that, the regulations on on-road autonomy are Wild West.
Wild West, absolutely.
Where Starsky did most of its stuff in Florida, the regulations are written that as long as you're insured, you can do driver out testing, which actually I've always thought of as a very wise regulatory strategy, because theoretically the free market of insurers they're taking the risk onto themselves. There's smart people who work in insurance. They should know how to write that risk, blah, 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 blah. And then I talk to the insurers and they're like, yeah, cool. All right, here's your policy. And it turned out, if I wanted to take a person out of a truck, which I desperately wanted to do, the only real person who would stop me was myself, which is terrifying, and part of why we took safety so seriously, because if we killed somebody, it would be Stefan up there with the CEO of OceanGate. And I think that's one particular way that people deal with the relative Wild West, and the other is let's hammer it out and let's get a thing under there, and whoops, it popped.
Yeah, exactly. I just did a quick Google search, by the way. It was the professionally built vehicle is the DSV limiting factor. That's the one with the meter-ish.
The name of it is the limiting factor.
The limiting factor, which is also great, not only because it's a deep dive vehicle, but that is the name from one of my favorite book series called The Culture by Ian M. Banks.
Yep.
Fantastic book series. Anyway, just wanted to bring that up for people if you want to start the Polymath Book Club.
So if we were to play our game, but do it with Titanic tourism, with people in the vehicle.
I do not nearly have the expertise to play this, but I will try. And I'm sure I'll get laughed at online.
I mean, how would we build something outside of just imitating the limiting factor? But how exactly would you get something that could deal with those pressures?
Yeah. Well, I mean, again, so to replay what they did, right?
Yeah.
Like it is a I think, a 5-ish meter sphere of solid titanium cast in a special foundry with machined in portholes and the whole oxygen system internal.
Yep. And do the portholes, do they work where like every increase of inch or two in diameter is an order of magnitude more weakness?
That's right.
Yep.
So if you look at the portholes, they actually
square law problem.
Yeah, exactly. So if you look at the portholes, they actually look very large on the outside, but on the inside they're like a pinhole. And so it's from a large diameter to a very small diameter. So you can see wider without having a very large surface area.
Really clever.
Right?
Yep.
Yeah, so it's a good design. Yeah, I mean the reason, I think I mentioned this, but the reason a lot of these submersibles are one-time use is they actually use a compressible foam.
Yeah.
The limiting factor did not do that. They did a buoyancy system based on some sort of electromagnetic weights that they could drop and something. Sorry, I'm getting a little bit out of my...
I mean, like, why? I mean, I guess like a thought that I have is like, why does it have to actually move all that much? Like, what if you dropped an anchor, followed a cable down, had buoys on top, followed a cable down?
Nobody has a cable that long.
5,000 meters long?
Yeah, that is... Oh.
No, there's definitely 5 kilometer long cables out there.
That can sustain the weight of this thing. Like, I feel like any kind of... The weight of that thing would sink whatever vehicle's trying to lift it.
I look at it as like they had a relatively small vehicle that had to ascend that stuff. But what if you had a very large brute force built, massive thing that just sunk and got raised, almost like a space elevator underwater?
I think you're still dealing with the cube law, square law problem, right? The bigger you make it, the even stronger it needs to be. So, that's why a lot of these things are tiny. That's why the guys on this sunken ship, unfortunately, were crammed in such a small space.
Yeah.
The bigger you make it, the crazier it gets.
So on the other hand, if it was just a cable, a person could go in it, ride down in solitude, in darkness, look at the Titanic
and then
from a
ride
fixed
back.
position and ride back for 6 hours on their own.
I mean,
curled up in a ball like one of those gunners in a World War II bomber.
This is actually why deep diving robots are actually so much relatively simpler to make. What you can do with those guys is you can just fill the entire compartment with mineral oil or some other non-conductive fluid, and then you don't have to make the walls thick at all because the fluid is non-compressible and it just dives as deep as you
Just another place where robots are better than people.
Way better than people.
And with that note, what are we talking about next week, Ilia?
I don't know. What do we want to talk about?
We can talk about Samsara more. We can talk about something else, and maybe, who knows, there'll be another disaster for us to dunk on.
Next week is July 4th.
Yeah.
So shouldn't impact our release schedule.
Fireworks robots.
Sorry, still a little foreign concept for the transplant Canadian.
And with that, thank you guys so much for joining us this week. Well, I'll talk to you soon.
See you next time.